One more questions? Homework questions? Okay, let's do an example of the last thing we did, and then I'll do some new stuff. And we'll head out. So, what a summary of today. Okay. So last time we did some crazy stuff like this. So I know it's been a minute since we did this. Anybody remember the first thing you should do with this? Yeah, it's kind of a big deal in this chapter 7. Pretty much somewhere it involves factoring. So how does this guy factor? The funny thing about these problems is there's built-in hints. Right? Yes. I'll bet you anything this factors like this, especially if I did it the way I wanted it to. All right, how we doing? And a lot, not all of it, not every single problem, but a lot of the problems in that chapter, the first step involves factoring. So, and now what can I use that factorization to do next? Get a common denominator. So what's this first guy missing? Yeah, so I give it to him. And then that last guy, what's he missing? That's crazy. And now does every fraction in there have the same denominator? Denominator. Yeah. So here's an example of like a place to stay away from in mathematics, unless you're really on top of what's happening. Sometimes students get to the point where they just cross through all this, and I think I said last time that you could do that if you're really aware of why it works. So why did I make all the bottoms the same? It looks like, well, thanks, Jeff, you just piled more shit on top of everything. It already looked bad. You came along and said, I'm a math teacher. How could I make that worse? But why is it nice now that I have all the same denominators? What can I do? Yeah. And why am I allowed to multiply by something? Well, because it is an equation. I have two sides that'll balance, right? Like good old Indiana Jones did not know his balancing equations correctly. Do you guys get that reference at all? Did you see the first Indiana Jones? All right. Complete your life and see that thing. All right. Sorry. I'm not a boomer. In my head, I heard something. Okay, boomer. I'm not a boomer. So if I multiply everything by this, and I can put it next to everybody, but basically it's going to cancel all those on both sides. You guys get that? So what's left alive? I got too many colors up here. It's freaking me out. 7x minus 14 plus 3x equals 5x minus 5. I mean, look at that shit. That's awesome. So you temporarily make it look a little worse because you got to get all the bottoms the same. But then you can get rid of the fractions because it's an equation. Now, the minute I show this to people, you want to get rid of every denominator you see. There's nothing wrong with having that once, but you cannot satisfy it unless it's in an equation. And now, that's easy shit, right? How do I finish this out?
Like times.
You got 10x minus 14 equals 5x minus 5. Subtract 5x. We might as well at the same time 14, because we're all good at this shit. 5x equals 9. And so x equals 9 fifths. You see, you guys remember this? What answers could I get here that I would have to throw out? Yeah, positive 2 and positive 1 are not in the domain of these things. So if I got them as an answer, I'd throw them out. I didn't. So I don't know if this is the right answer. I didn't check it, and hopefully I did all this shit right. But at least I know it doesn't freak anybody out. So I don't have to throw it out automatically. How you guys doing all right? All right. Let's try one more. Because I didn't like that answer. Oh my God, dude. Oh, I almost got it. Oh, I see. I almost got it. All right. Example 2. Oh, this might be really horrible. All right, let's see. Screw it. This is going to come out gross. Too bad. It doesn't matter, Joe. Yeah. All right. Just a little warning, we might not be able to do this one all over. There's a point I want to make with this problem, and I almost don't care if we can't solve it all the way. Can you guys identify what might be the trickiest piece of this? 3. Because students will look at it and go, I don't need to worry about him. He didn't have a bottom. Of course he's got a bottom. Everybody's got a bottom. That's strange. It's a good clip. So what's he got on his bottom? 1. I like that. And of course, what piece do I start with first? Yeah. Oh. If I were you guys, I'd just sit there. So what's he going to do? He's going to drop to the floor? So you can see people will just not do that, and they'll think he's fine, he needs something, and then the 3 just kind of stays a 3. That doesn't make any sense. So what's he missing? He's missing everything. So yeah, I would give him an x squared minus 9. Because he's missing both of these, which is this. He's got everything. He's missing x plus 3. Does everybody have the same denominator now? Yes. So I can now do what? I can multiply both sides by that denominator. Just multiply everything by this, so it cancels there, there, and there. You guys really cool? I mean, I'm doing it on both sides. I'm just not writing it. And what on this side it distributes to this and that. That's why it cancels both. It's okay if you don't understand. It's fine. But you gotta ask. You gotta say something. I see some of your faces. I'm like, there's a question in there. Why are they not asking? Okay. So let's see. What do we get over here? What's left alive? 3x squared minus 27 minus 2x 4x plus 12. Now, trying to make this up on the fly, I don't know. I might have lucked into it as working, but I would have put $100 on I didn't. I'm a teacher, so that's saying a lot. So 2 things I wanted you to see. 1 is if you have a whole number, it still has a denominator. It still has to be the same denominator. 2, if you get to this point, what tells me how do I solve this?
Put it to 0.
Why? because you got a higher power than 1, right? It doesn't matter where the equation came from. I know I've got to get it equal to 0 if I've got a higher power than 1 on one of my x's. Because then I can't get my x's together. I have to use that new process we developed last chapter. So I can subtract 4x, subtract 12. So I get 3x, let me put it in order too, minus 6x. Now the neat thing is, huh? No, well, I'll tell you this, it's not going to work. You can divide everything by 3. Do you guys see that? So if I divide both sides by 3, that's nice. But then what's wrong with this?
Oh, 13 is prime.
Yeah, it could only be 13 and 1, which will never make 2. So I know some of you guys know how to solve this. QF, quadratic formula, but we're not officially there yet, so you can't do that. Sure.
When do we get there?
Not now. Actually, we don't get there in this class. Oh, I'm sorry.
No, but I want to tell the story, the quadratic formula, remember?
I'm sorry, man. Oh, it was tough. So you guys understand I made that up totally, and this we can't currently do officially. You could, there's a method, and most of you guys know it, quadratic formula, you can solve it, but it's not factorable. That's when quadratic formula is useful. Okay. The point I was making there was, what the shit do you do when there's a whole number? It still has to be taken into account. And then what do I do when I get a higher power than 1? Well, I know, I make it equal to 0. We know that. Doesn't matter where it came from. Okay. Anything else about that before we get into the next chapter like crazy people?
Sorry?
Yes?
About the denominator that I asked you before about the changing sign.
Oh, all right. Yeah, because there's a few problems like that in the
Yeah.
book. All right, what if I had this? Let's do a quick one here.
Yeah.
Okay. Is this an equation? Oh, so I can't kill any denominators. I must control that urge. The Dexter of math. Don't do that shit. All right, what do I do first then? Yeah, factor's a good thing to do. How do you factor x squared minus 25? You guys notice a problem? One thing that I see students do is they give this guy both of these, and then they give this guy this one. Which I understand the reasoning, but my God, holy shit. Isn't that almost that?
Mm-hmm.
Why is that not that?
The x is negative on that side and the front is positive.
Yeah, so they are the same, just one is the other one multiplied by -1. So, there's a few different ways. How do I factor this? Take out a -1. Now, I'm not saying -1 has to be included in the LCD business. No. All you do with this, you put it on the 3, right? 3 divided by -1 is -3. Okay, I took care of the -1 shit. So I want you to realize what we just did. 3 over 5 minus x is the same thing as -3 over x minus 5. That's the same thing as me saying 4 over -5 is -4 over 5. Isn't that true? So the negative can be on the bottom, or I can take it out of the bottom and put it on the top. That's really what we just did. Now I do this like I do all the other problems like this. What's this guy missing?
X plus 5.
X plus 5. Ooh, you're multi-complicated. Go for it.
So we don't change the plus. We don't change it.
Oh, yeah, you could put the negative there, but I just didn't want to erase it. I just want to add something. Question.
Thank you, sorry.
Plus, if that was a minus, my suggestion is to do this anyway, because now I can see the -3 goes through. Remember that? So it's kind of set up beautifully. So now I've got 4 minus 3x minus 15 all over. Why can't I get rid of that damn thing? We made them the same, Jeff. Same thing we did over there. It's not an equation. I don't have 2 sides to balance things out. I like it.
So it's just ends up.
So you keep,
And then
so you keep the bottom because you didn't.
this side, I'm allowed to multiply by something because it's an equation. So I got 2 sides to do that to, so it maintains the truth. If I had half a dollar and somebody else had half a dollar,
You got
I
a
can't
dollar.
say, hey, we got $2. Do you see what I'm saying? It's not an equation. I can't kill the denominator. Sometimes I wish I could. But too bad for you. All right. I really, and of course I'm not done. I don't know if anybody out there is like, what's going on? Why am I not done? Yeah, just put the like terms together. If there's an equation, I'm allowed to undo division. Because I can multiply both sides to kill division. No equation, I'm not allowed to do that shit.
Okay.
Good. Accepted. Like it. Oh, example. There you go. Okay. Anything else from that last chapter that is lingering in your brain? If you haven't done the homework yet, what the shit?
I have a job, Jeff.
So do I. So did I? I had 3 jobs. I don't want to uphill both ways. I lived in the Mobius strip.
Drink my coffee from the. What's the pitcher? I jumped into this feet
Klein
first.
pitcher.
Klein pitcher. I was thinking the Euclidean. That's a thing, right?
Euclidean is a thing. Euclid. Yeah.
Well,
Euclidean.
there's Euclid Avenue.
Look up non-Euclidean geometry if you want to freak yourself out. All right, so a little bit of the next chapter. Well, everybody's aware of what's happening in the near future. Next Monday is officially the last day of class. I was considering, I wanted to see if you guys were cool with like,
A pizza party.
we could either do that or we could just not meet so you guys could study for your other finals. I didn't even realize Monday was still a class, to be honest. I always forget when the college does that. Oh yeah, that was Monday, let's do that.
Some of my other classes don't even meet like this whole week. I had my final for ASL on Wednesday.
Tell any administrators.
I don't.
I don't not have
ASL, investigate.
No! Don't be a scout,
Ollie
Jeff.
Face.
Not my legal name. They'll never find me.
Alright. So if there's no other questions from the last chapter, let's get into the
There's like 2 bases at this whole school. So, me and my brother.
I know you're a student, I do know. So the next chapter is all about,
I don't even know it.
if you ask me, I can find out for you.
Recite it
The
right now.
next chapter or the next section?
It's 2. Huh?
The next chapter or the next section?
Next chapter. Yeah.
Is chapter 8 the last chapter?
No, chapter 8 is what we just came out of. This is the last chapter, chapter 9.
Okay.
Yeah.
Never mind.
You guys all got the homework sheet, right? So there shouldn't be any surprises.
Oh,
When-
so we're
when-
just, we're not, we're just having a final
last year.
test.
Yeah, there's no more tests. There's
Okay.
just a final.
I
There's no more
updated.
quizzes?
Right. Huh?
No more quizzes?
We're probably gonna have a quiz. Yes. In fact,
No.
oh, everybody's gonna hurt you. But I did want to have a quiz tomorrow. I might as well put it up here now. I was gonna put it up there later. Quiz tomorrow on basically on chapter 8.
Just so you know, I work again tomorrow, so I'll be a little bit late.
You don't know.
Oh,
That's us.
it's not Marcella's
Supposed
fault.
to leave at 12, but
I already
I
decided
also
to have a
work in
quiz
Mission
tomorrow.
Beach, so
So don't jump right out there, okay?
radical.
That'll be our last quiz. Yeah, round. All right. Let me just put this up here so you guys know this. Let me ask you this, actually. What squared is 9?
3?
Positive.
There it is. Every real number, I'm sorry, let me say this. Every positive number has 2 real roots, 2 real square roots. So some of you guys are like, where's the whole negative thing not allowed to come in? Well, it's going to come in a second. But obviously, what do I square to get 9 would be plus or minus 3. There's 2 roots, right? What do I square to get 0? No, come on. Well, sure, but what's plus or minus 0? 0. And what do I square to get negative 16? Yeah, dude. There's no real number you can square to get negative 16, right? You guys with me? Try it. 4 times 4, up. Negative 4 times negative 4, up. So there is the idea of imaginary numbers, which will be in the next semester.
That sucks.
I know. Because I love imaginary numbers, and they're nowhere near as freaky as they sound. Anyway. So if the book asks you what are the roots or what are the square roots of 25, that's plus or minus 5. Here's where the whole negative thing comes into play. If I write the symbol, this symbol, that is the positive root. So that symbol is defined, it's actually called the principal square root. And it's just defined to be the positive root. So if I like I said root. If I wanted a negative root, just put a freaking negative on it. So to get both answers, this gives me the positive 3, and this gives me the 3 with a negative 1. Negative 3,
I covered up the negative, and I was like, huh? It's fine.
yeah. I heard you coming in, so I'm like,
Just clothesline me there.
you guys with me?
Mm-hmm.
I don't know if you've ever heard that symbol actually is defined to be the positive root, because there are 2 roots for positive real numbers. Can you guys, what's this?
Yeah. Plus or no, that's positive 11 because it doesn't have the.
Good, it's got the symbol, so it wants just the positive. So what's this?
Negative 4.
Did you see how that one works and that one doesn't? Because the negative's on the outside. Square root of 16 is 4, and then you put a negative 1.
So if the negative symbol wasn't next to the
If
square
it's
root, it would
inside,
it'd be
what's the square root of negative 16?
something stupid.
Not real. But not stupid.
Oh.
So it's not real. Okay. Alright. Maybe. Does it sound vaguely familiar? So that's what we say right now. If I ask you the square root of a negative number, you just say not real. Don't say undefined, because it is. We just don't know what the definition is yet. All right. So let me go one extra step that the book doesn't, because I'm insane. What do you think this would mean? Hebrew. So here's the neat thing. If you guys do take 103 or 110, you're going to hit stuff like logarithms and all this kind of business. I don't know if you guys have ever heard of that.
Yeah, it's what lumberjacks chopped down.
Exactly. There are really stupid math jokes about log cabin and all this kind of stuff. Abraham Lincoln with math equations he loved, just me. Whatever. Obviously, I'm very impressed with it. But the big deal is, anytime you learn a new symbol for a new function, it's all about getting in your head what the symbol means. So why was this relatively easy? Because you've internalized what this symbol means. You actually can read this math sentence. Sort of like if you're starting to learn a new language, you have to take a second and translate it before you can go. Whereas if you know 2 languages, you can speak in both without really having to translate. Is what I assume it's like. Actually, I know Mathish and English. So what does that symbol mean? Why was the answer 3? What is the symbol asking us?
Positive square root?
No. Not read the symbol. What is the question it's asking? What does it take? There's a few different ways to say this. What does it take 2 up to multiply to be 9? Right? That's really what that means. So then what is, and there's an understood 2 here. We just don't write it because we're lazy. And the square root is the most often used root. So we just said, we're going to use that one the most. Let's just not put a 2. Everybody knows there's a 2. So what does this symbol mean? What does it take 3 of to multiply to be 27? Kick ass. And it takes 3 what? 3 3s. 3 times 3 times 3? 27. So this does not mean 27 divided by 3, because we already have a symbol for that. Divided by. Why would we? Well, we are math people, so you know. Okay, maybe?
Yeah.
Okay. So the book actually doesn't get into this until section 9.7. It's got a whole higher roots section. So we're not even going to see these higher roots in what we're doing. Except for this, what I showed you. Okay, so let me see. What about this? Let me really freak you out. So I'm going to tell you. I'll give you a little hint. The answer is not your first instinct. What is this?
Ha! X.
All right. See what I just said? That's not the answer. Why? Now think about it. What could X be? What can X be? I mean, no, don't give me specific values.
Any number.
Any freaking number. Could X be a negative number?
Yes.
Of course it can. No. This is not the right X. I haven't written shit, have I? So if X was negative 4, keep going with this. How do I complete this?
16.
What's negative 4 squared? And what's the square root of 16? 4. So the square root of x squared cannot be x because I don't get negative 4 over there. In fact, we know the answer to a square root has to always be positive by definition. We said the square root symbol wants the positive roots.
So do we put the bars with the 2?
Tubular. What makes everything positive?
What do they call it? Absolute value?
Yes.
Yeah.
Yes.
Yes. Horrible way.
I know that's really freaky because your first instinct, I know, is to do this, but if you just think about it for a second, he could be anything. Damn it. So let's try this. Watch. Square root of negative 4 squared is the absolute value of negative 4. Using that definition, sure, shit, yeah, it is. Huh. All right, I like it. Cool. I did a Walt. All right. So let's try one step up from there.
We don't have to.
Yeah, we do.
You know I do this every class, and we always just say value. We have to. It's math.
So would that be x the absolute value of x squared?
Maybe not.
Because it's you need.
Why did this guy? Do you guys all agree it's some kind of x squared? Because what does the square root do? It cuts the thing inside in half. So square root of 9 is 3. It's related to x minus 3 x plus 3. It's related to like a difference of squares. You're cutting them in half multiplicatively. So it does make sense. This should be x squared. Does it require absolute values?
Yes.
X squared is always, when you square something, you get a positive number, right? Or 0 at least, right? If you put an absolute value around that, I wouldn't take points off, because it doesn't actually change anything, but you don't need them. All right. What about this here?
X.
Is this right?
Do we need the absolute value?
Yeah, because what's like negative 2 cubed? Negative 2 times negative 2 times negative 2 is still going to have a negative sign.
Wait.
So it looks like every time there's an odd power, answer is going to need an absolute value because the answer can't be negative. So if the answer could be negative, but if I don't put them, I better put them. Cover my ass. Yes?
So it means that we divide the exponent without. We divide the exponent with the.
Yes. We are farmers. If I said factor this, what form is that in?
The difference of squares?
Difference of squares.
Yeah, I just
Because I can
guessed.
cut everything in half.
Square. Yeah.
So when we do this factoring, we are taking square roots. Roughly. Because what I cut this in half, so I get,
X3. The last day.
and I cut that in half and I get in there. I could have been really evil, put a 1 there, because then this would have been both cubes. Oh shit.
Yeah, X3 the last stand.
Let me stop for a second. You guys, so here's the thing. I really,
I'm tired.
especially if I live. I really want to show you this. You guys know the square root symbol. You know it.
Yes.
Right, before I even put anything up here, you'd already seen it before. And you know me, I just have to hate shit for some reason. Sometimes. Square root symbol never had to be invented because square root of x is x to the 1/2 power. What do I do? What's the square root symbol mean? Cut something in half multiplicatively, right? What's the exponents based on? What operation are exponents based on? Multiplication. So this means half of x multiplicatively, which is exactly what a square root does. Real quick. What's the square root of 9 again? 3. So what if I wrote it like this? Stay with me. Isn't 9 3 squared? Is that cool? What do I do with powers in this case? What do I do with a power that's raised to another power? Multiply them. What's a half of 2?
1.
All right, so isn't the square root of 9 3?
Yeah.
So 1/2 power does the same job a square root does. We never needed to create a square root symbol. But most of us are familiar with it, so we don't kill it. Sort of like America's probably never going to use metric because holy shit. Get everybody to go to metric? Ain't gonna happen. All right, so that's just for your own personal knowledge. Let's come back to something we actually have to be able to do here. What do you guys think about this? Let me start to number things.
I like it because I can't read it without the glasses.
So blurry.
So I don't like it as much now. We just cut everything in half?
Yes.
Everything?
Yeah, so square root of 9 is?
3.
It's crazy. Square root of a squared?
A.
A.
Oh, that's
Square root of b12?
The absolute value.